Library we're going to introduce in our data science course is Numpy. And let me tell you something before we even begin, and it's that you will not be using Numpy directly so often. 70-80% of your time as a data scientist will be spent using pandas, another Python library that of course we're going to dedicate most of our time. But pandas is built entirely on top of Numpy, is 100% dependent on Numpy. Numpy is the library that started the data science space in Python, is the one that kicked things off. So I would even risk to say that it's the most important library that we have in the data science space. Again, you will not be using it directly so often, but it's really important for us to introduce it because it has a couple of really important concepts behind efficiency, performance, and also a couple of new APIs introduced in the data science space that they will also be borrowed by pandas, like for example, vectorized operations, Boolean arrays, etc. Numpy is an extremely simple API. It has two major components. Data types, it has a really good catalog of data types, and also arrays. And that is it, okay? It's primarily an array-based library. It's just to manipulate arrays. And this catalog of data types, it's not crazily huge. It just has numbers, floats, integers, and it also has a couple of others, like for example, dates, but mainly we will be working with numbers. Numpy is a library especially created for numeric computing in Python. So why people created Numpy, why it was created? Well, Python is a really good language to write our code. It's really fast to write the code, but it's not so fast to execute it. It's not even comparable to something like C or Java, right? In terms of numeric computing, the closer you get to the middle, right, with a compiled language like C, the faster and more efficient that your computations are going to be. Also, other languages like, for example, C or Fortran are a lot more efficient when storing objects or numbers in memory. So this is the first thing we're gonna see. How what are the differences between storing simple objects or simple numbers in Python and in Numpy, or for example with C, which is kind of similar to the way Numpy is going to work. So the first thing is kind of counterintuitive, but when you're storing a Python number, right? So let's say you want to create the number 4, you just want to do something like, I don't know, x equals 4, and you have just defined that variable. In memory, you're not only storing the number 4. Python, as it's an object-oriented programming language, and as we usually say, everything is an object. When you are creating the number 4, you're also attaching in memory a bunch of object-related data that is unnecessary to the number itself, right? In comparison to other languages like C, which just store that given number. So for example, if the number, we need 4 bytes to represent this integer. For example, we could even use 1 if we want to be really efficient. But let's just say we take 2 or 4 bytes to store the integer. In C, the amount of memory that it's going to be used to store this number is going to be 4 bytes. In Python, it's going to be those 4 bytes plus the entire extra space required by that number. There's this really good blog post by Jack van der Plas, but it basically has this idea of the difference between a C integer or the Python type of integer. The same thing happens with floats, but in general with numbers, which explains it a little bit more. At the end of this Numpy section, we have also reserved a lesson that pretty much compares the actual size of Python numbers compared to Numpy numbers. What you're gonna find is that, and this is kind of a spoiler, a Python integer is gonna take up to, for example, 28 bytes in some cases. That is a lot to store just one simple number. So let's get started with Numpy. Again, you understand that it's going to be a lot more efficient. It's going to provide efficient computations. It's going to be a lot more performant when running these numeric computations. So as I told you, NumPy is all about arrays. We will be creating these arrays, and this is the number one data structure that NumPy provides. But it's an incredibly flexible one. That's why we can even have an entire library that just surrounds our arrays, because it's the only deal, that one job that NumPy has is managing arrays. So let's get started, and I will be comparing arrays to, of course, Python lists, because they look a lot the same. And actually, in the way we are creating an array right here is by passing a list of numbers. So we are creating a NumPy array, right? We import NumPy as NP. This is kind of a convention. And we create this array passing a list of Python integers. Internally, NumPy is storing this amount of memory. It's allocating the contiguous section of memory to create its own type of numbers, which are, again, as I told you, a little bit more efficient. Usually a lot more efficient. Usually you will not be creating these arrays just manually. You're reading them from some data source. So that's why it's kind of silly to first create the numbers and then duplicate them in an array. In this case, it's just for educational purposes. In real life, you will be reading this data from some other source. So let's start with the basics, right? These will feel a lot like a list, like a plain old Python list. It just feels, it has the same interface. So for example, indexing. These arrays are indexed starting from 0, the first element, up to -1. So all that is the same. If I want to select the first element of A is number 1, I just do A at 0. I want to select the second element, it's A at 1, etc., etc., etc. Slicing works in the same way, and you include upper limits, lower limits, etc. The upper limit is not included as usual. Everything is the same. The negative index also works, so you can say everything starting from the second element up to the last one without including the last one, right? Because the upper limit is not included. This is the same thing that happens with Python lists, and you can also provide a step. So far, so good. Everything is pretty much in the same way as it works with Python lists. But NumPy is going to add a couple of new methods, APIs on top of regular Python lists that it's going to make easier our management of arrays. The first one is the multi-selection one, which is very simple, and basically it is as it goes. If you want to select multiple objects from the same array or the same list in Python, right, what you can do is just invoke, right, from this array, I want to select this element, and also from this array I want to select this other element, etc., etc., etc. You put them one after the other. When you execute this, what is generated is basically a tuple of all the results that you selected. NumPy introduces this multi-selection where you can say from this array I want to select, and you pass a list of multiple indices to select. And as you can see, it will return pretty much the same result, but now it's going to be wrapped in an array. So what you're going to see is that NumPy will always go back and forth from arrays to just one sort of scalar value to back to arrays, etc. So for example, the result of this step selection is another array. The result for this selection is also an array. So again, NumPy will try to stay within arrays or their own type of scalars all the time. One important feature of arrays in NumPy is that they have a defined type. It's not as with Python lists that they are heterogeneous. In this case, arrays have a defined type. Once you create an array, for example, our array A has a given type, which is integer 64. Is the default type of an integer in NumPy. Actually, if you again go to the last section, the last lesson in this section, you are going to find the multiple different data types available. The other array we created, the array B, has the type float 64 because the numbers inside are floats. And actually, you will see that even the ones that look like arrays, like integers, sorry, like the number 1, it is also formatted as a float because it's not an integer, it's the float 1.0, okay? The idea is that Numpy, to make things more efficient, will assign a fixed data type to the entire array, and it cannot be mixed. You can't have in the same array floats and integer. Actually, if you have both of them, Numpy will default to floats. It will create all of them as floats. So far, the arrays we have created were assigned the correct data type automatically. Just the Numpy decided the default type and assigned it without us worrying. You can set the default type if you want. So in this case, we're creating a Numpy array with the type float. So these are all integers. By default, Numpy could have created an integer-based array. In this case, they are all floats. Numpy included also other types of data types. For example, you can create an array of strings, which Numpy will define as objects. In this case, this is the notation for Unicode. This is related to the machine, the platform. But we usually refer to these strings as objects. And you can create arrays of multiple other things completely unrelated that in this case we're adding a dictionary and a module, okay, completely unrelated. And the type here is an O also for object. So usually you don't want to use Numpy for these or for these. You don't want to use Numpy for objects, sorry, just go with a Python list. Another important feature of Numpy are the arrays that can have multiple dimensions. So it's the same object, the Numpy array, but it can have multiple dimensions. In this case, we're going to create a two-dimensional matrix, right? Conceptually, this is a matrix, which again is a regular plain old Numpy array, but it can have multiple dimensions. Once you have created one of these, you can expect the shape of it. It's basically 2 rows by 3 columns. And the number of dimensions is, of course, 2. The total size is 2 by 3, 2 times 3, 6 total elements. And you can keep increasing that number of dimensions. So, for example, this is a cube, right, that has 2 by 2 by 3. So the shape, again, is 2 by 2 by 3. The number of dimensions is 3, it's a cube, and the size is 2 times 2 times 3, the total number of elements. You have to be really careful when creating multi-dimensional arrays because they have to have the correct dimensions. If you fail, like in this case, we have 2 things outside. Internally, in one of them, we have 2 other rows, we could say, but in the second, we have only 1 row. Numpy will not be able to interpret this as a cube, and it will just create an object array that has only 1 object, 2 objects, so it has only 2 elements, those objects all together. So the first one is this list. So in this case, again, this is a bad example because we're missing, right, the required second list to create the correct number of dimensions. Indexing and slicing with matrices is extremely simple. Not just matrices, multi-dimensions with Numpy. We're going to use matrices as the most common example. In this case, by default, you will provide the regular selection, and you will have multiple levels of selections. The first one, right here, is selecting by row. So in this case, you say from the matrix A, give me the row at position number 1, which is 0, 1. So this is row number 1. Once you have this row, this is just a regular array, so you could just directly give me the element at 0, the first element of this array, or you can put all in the same expression. You can say from the first level row, give me the element at position 1, from the second level column, give me the element at position 0. This is, of course, the recommended syntax, as you can see, gives us the same result for these sort of multi-dimensional arrays, especially when you have more dimensions, like 3, 4 dimensions, etc. Selection works in the same way, but sometimes it might be a little bit counterintuitive. So in this case, you say, I want to select from 0 up to 2, and this is the first level, right? There is nothing else here, just this is the first level. So there's going to be 0 to 2 of the rows. Give me the rows starting from 0 up to the row in position number 2, which is this one, but it's not included because it's the upper limit. So it gives us 1, 2, 3, 4, 5, 6, right? You can use slicing with multiple levels. This is perfectly fine. And in this case, we say, give me all the rows, but from the columns, give me from 0 up to 2, right? The last one is not included. So we kind of select this window here, 1, 2, 4, 5, 7, 8. You can experiment with the selection, and there are many examples. Just run this notebook and run all the experiments. Once you have these matrix, you will see that modifying it is extremely simple and kind of intuitive. In this case, we're replacing the entire row at position 1, the second row, with the array 10, 10, 10. And what happens if I replace the row in position number 2 with the number 99? This is a matrix. I can't put just 99 here. Numpy is smart enough to expand that single scalar we provided into the whole dimension.